express the triple integral of f dv as an iterated integral in spherical coordinates for the given function and solid region. Okay, so here we go. So we need limits for theta, phi, and rho. So theta looks like it's starting, this would be theta equals 0. Right here is theta equals pi over 2 up until 3 pi over 2. Okay. Now phi, this is where phi is 0. So there's nothing up until here. What does phi equal right here?
Pi over 2.
Pi over 2 up until there's stuff down here. Phi doesn't go past pi. You don't need it to because theta is taking care of the portion of the solid that's over there. So we're just going to go from pi over 2 to pi. Good? And then rho, 1 second, you can do the same thing where you draw the little arrow outwards from the origin. Where does it start? 2 up until 3. Good. What's your question, Anirudh?
So basically, for how we look at theta is the x, y plane? And then,
Yes.
And then for phi, it's the y, z plane?
I just look from the positive z-axis down.
Okay.
You don't have to necessarily look at the yz plane. It can rotate around.
Down in which direction?
Down towards negative z. So you start at positive z-axis, and you look as it goes towards negative z-axis. So always starting here, that's where you start, down to there.
So we could have said it goes from z to like x and say that is pi over 2 and then go one more.
Yeah, you don't have to look at the
Just
yz plane.
orientation doesn't matter, it's just like, okay.
Yeah, because there's nothing.
Yeah.
And then, well, it's dangerous to look here, though, because the solid's not over here, right? The solid's back there.
I imagine that way, like going from z to the x, negative x, then sweeping it down here more.
But there's nothing here.
No, like, but sweeping it to only pi, from like pi over 2 to pi, kind of thing. But
Yeah.
from like that side.
From this side.
Yeah.
You looked, that's okay. Yeah, that's pi over 2 all the way down to pi.
And
Uh-huh.
So what you said about pi over 2 to just pi, not 3 pi over 2,
Right.
because our theta handles it.
Yes.
So
Phi always is between 0 and pi. It won't go to 2
Write
pi.
that down.
It won't go to 2 pi. Only theta goes to 2 pi. Yes.
So E is only a quarter of the sphere?
Yeah.
Yeah, hollowed out, too.
Okay, so what I did was I did the whole sphere, and I went from E from 0 to pi, and then theta from 0 to 2 pi, and I just decided to flip it right here, okay?
Well, you're getting the right answer in the end,
Yeah.
but you should set it up so that the triple integral represents the solid that's pictured.
The quarter of
Yeah. And then the other thing is, like, this integrand, f, is symmetric over E, so you ended up getting the right answer by doing that. But if this was funky and not symmetric with respect to the origin, then your method wouldn't have worked. Because who's to say f has origin symmetry? You cutting it into fourths worked out because E is symmetric with respect to the origin, and so was f. But if one of those conditions doesn't fall through, then the answer wouldn't be equivalent. Yeah. So just, I know this one's funky because it's not in like the first octant or somewhere we're used to
I
looking.
just didn't know if E was pointing either to half of it or just a quarter.
Quarter. Yeah, you're right. And scooped out, right? The little part in the middle. Are we okay? You don't need me to do it, actually. We're good. Okay. That look of disgust. You're like, don't do it. Don't do it. Okay. 27 says,
Wait, Professor. So
Yeah.
One last question. Will it always be okay if we just go from z in the y-axis, though? I know
what if it's not living there, though? What if it's living like over here?
I see.
So don't be so dependent on having to look right there. Look where the solid is. Yeah.
Hey, Professor, so phi will always be from 0 to pi? Is that-
Tops. Yeah.
Tops, okay, got it.
Or less than. 27, evaluate triple integral over E, x e to the x squared plus y squared plus z squared dv, where E is the portion of the unit ball, x squared plus y squared plus z squared less than or equal to 1 that lies in the first octant. Okay. Who needed this one?
I do.
Oh, let's set it up. So unit ball, instead of saying unit sphere, means it's filled inside, right? Because it's an inequality. X squared plus y squared plus z squared less than or equal to 1. And we're just in the first octant. So here, here, and then it's just this piece like this. I would highlight that maybe just so you don't forget, right? So you don't get carried away. Okay, so let's come up with our limits. So theta, this is where theta equals 0 up until pi over 2. So far, so good? Okay, phi, this is where phi equals 0. There's stuff stops at. Very good. So 0 to pi over 2. And then what about rho? So go from the center, 0 to, where's that? 1, right? This is rho squared less than or equal to 1. So same as rho less than or equal to 1. Okay? And then the integral's a little annoying. Do you need help integrating?
Yeah.
Okay.
Yeah.
Okay. So we'll go 0 to pi over 2, 0 to pi over 2, 0 to 1. What's x in spherical?
So it's like rho, sine, phi, cosine, theta.
Beautiful. Times e to the,
Rho squared.
beautiful. And then what's dv in spherical?
Squared,
Rho squared, sine phi, d rho.
d phi, d theta.
Yeah.
Oh, yeah.
Okay. For some reason, I have a hard time not writing del when I write d rho. Have you found yourself struggling with that? No? Okay. Okay.
I keep writing like theta.
Oh.
Wait, so del and rho are completely different.
Yeah,
Simply-
but they're just curvy and they look, one looks like a D and one looks like a P with the tail, basically, right? Okay, now here's one cool thing, guys. All our limits are constant. And everything's a function of rho times a function of phi times a function of theta. So we could just split this into 3 Calc 1 style integrals. Do you see that? Okay, so immediately do that. So 0 to pi over 2, that's for theta. I just have cosine theta, right? D theta. Then 0 to pi over 2, that's for phi. What do we have? Squared, right?
Oh, yeah, sine squared.
Because there's 1 here and 1 here. D phi. And then lastly, 0 to 1. Very good. Rho cubed. Good. D rho. Good? Are we okay? All right, so let's knock them out one at a time. Let's just do 1, 2, 3 like this, and then we can multiply everything together so we don't lose our minds. 1. Okay, hopefully this is relaxing. You can feel good about yourself. Antiderivative of cosine theta. Good. I'm hoping it's, you know what I'm hoping it turns out to be. It's not, but 0.
Oh, no, 1.
I mean, I wish it was 0, right? Because then I wouldn't even do the other 2. But we're not so lucky. Okay, 1. Good? Next one. 0 to pi over 2, sine squared phi d phi. What do you do? Quick as a bunny? Yes. So 1/2, 0 to pi over 2, 1.
Minus cosine 2 pi.
Good. D phi. And then we have 1/2 phi minus.
1/2
Very good. But keep the 2. Yeah. 0 to pi over 2. And then this is going to be 1/2 pi over 2 minus 1/2 times that sine of pi, so 0, right? Minus 0 plus 1/2 times sine of 0. So what is this? Yes, very good. Pi over 4. Okay, we all right? Last one's the spiciest one. 0 to 1, rho cubed times e to the rho squared d rho. Yes? So you need to think of this rho cubed as rho squared times rho. And we are going to do a U sub, and I am going to bother to write it out. Can you believe it? I'm going to do a T sub first, because can you tell when you make the substitution, it won't be done. You're going to have something extra in there, so we're going to need to do by parts after. So since I know by parts is coming, I'm going to save U and dV, although we'll probably do tabular, so I guess it's not the end of the world if you didn't catch that. But anyways, I'm going to let T be, take a guess,
It's rho squared.
rho squared. Then dt would be 2 rho d rho. So 1/2 dt is rho d rho, which I have right here, rho d rho. Then this is going to be e raised to the,
T.
that's t. And then what do I do with this extra rho squared?
There's T.
That's another t in there. And then my limits, t is rho squared, they're going to stay the same. 0 squared is still 0, 1 squared is still 1. So those don't change. So we're going to basically have 1/2 0 to 1 t times e to the t dt. How are we doing? Good? Okay, then from here, you could just do classic by parts. Let's just do tabular, because it's faster. So we have, in the first column,
T.
t, and then,
One.
yeah, and then e to the t over here. So keep going till they match. And then we'll have plus, minus, yes? Okay, so then we've got 1/2 t e to the t minus e to the t evaluated from 0 to 1. So that's 1/2 e minus e minus 0 plus e to the 0. So just a half, is that right? I'm freestyling here. I'm not even looking, because I can't make sense of what's going on over here. Okay, whatever. Who cares? I don't know what I did back in the day. Okay, so we have 1 times pi over 4. Is the answer pi over 8?
Yes.
Woohoo! Like, we can't get them wrong, even if we try, huh? We can't get them wrong. It's not, you're not there yet. It's okay. It'll happen one day.
I didn't see that we had to like split it up.
You didn't? So you just, oh.
I tried like doing it in.
I mean, it'll work, but there's too many opportunities to make a mistake. So here's like, it screams at me when all the limits are constants. Do you know what I mean?
No, sorry, I split that up, but I didn't split up like the row into like row squared.
Oh,
and then row e to the-
yeah. So that's just, I don't know, when's the last time you took Calc 2 and you practiced some integration techniques where you had to do a U sub and by parts, you know? Like me, always. You guys, if you're tutoring, right? Don't I tell you? I tell you tutor as your side hustle, because then you'll be helping people whilst refreshing your memory of your math knowledge. So then like you would have remembered if you tutored some high school kid the other day and you were helping him integrate, you'd be like, oh yeah, no big deal. Yeah. Okay, that was fun. 31. No centroid. I said it in the homework, but I forgot to do it for the other one. Is that what happened? On 31, I told you just to do part A?
No, yeah, you said that part A.
Okay, who needed 31? Find
Yeah,
the
I did that.
find the volume of the solid that lies above the cone, phi equals pi over 3, and below the sphere, rho equals 4 cosine phi. Okay, let's graph it. Do you remember, Vincent, I told you guys the shortcut yesterday when you graph a sphere like that? So you don't have to write it in rectangular coordinates, how we know the graph's going to look. Do you remember what the radius is? Yeah.
Cosine T.
So then where's the
0, 0,
center? Tell me the coordinates of the center.
0, 0, 8.
0, 0, 2. And the radius is?
2.
2. That's the most, either the sphere is centered at the origin or it's like this, and it's centered on the z-axis. They don't spice it up much more than that. Okay? So let's graph this sucker. Do we need to find intersection to proceed?
No.
No, we don't. Isn't that nice? Look, we could just be lazy in spherical. Look at us being so lazy. 1, 2, 3, 4. Okay. Then we're going to make a sphere. Cooperate, sphere. Please. Perfect.
Does cosine lie on z or y?
It lies on the z. We derived it yesterday. Reference your notes. Okay. There's the center. Above the cone, phi equals pi over 3. Do I want to actually find where they intersect? I can do it very easily. Rho equals 4 times cosine of pi over 3, 4 times a half. So when rho is 2, they're going to intersect. Okay, so that's going to be there. Okay, that was easy. Why was I being dramatic? Okay, above the cone and below the sphere. So what is this looking like? Snow cone again, huh?
They love the snow cone.
They love that snow cone. That's why I'm telling you, like, once you've done enough of these, you're like, oh, this old problem. This old problem. They just switched the radius on me. That's all. I told you we wouldn't need the saddles. Have you graphed a saddle? Have they asked you to graph a saddle? I told you. Okay. All right. You ready? Vincent, are you ready?
Yep.
Theta's going to go between
It's from 0 to 2 pi.
all the way around, right?
Yeah.
What does Gupta say? He told me, he goes, you're at the club. I don't know why I'd like this. I don't know if the lights are going around or something. He has some
It
analogy.
says about like talking loudly. He's
But you're
"We're
at the,
club,"
he was like, when it's 0 to 2 pi, you're at the club. I'm like, what's going on? Okay. Phi is going to go from, here we go, 0 to pi over 2, yes?
Pi over 2.
Doesn't go permanent.
Last time it stops at pi
Oh, shoot, it stops at pi over 3. I've lost my mind. I've lost my mind.
Pi over 3.
I was pretending I was at the club, and I forgot where I was. Okay. There we go. So sorry. Okay, are we good? And then rho. Ooh, this one's tricky. Is rho going to be the same distance everywhere you go?
No.
So that means it's not a constant.
It's a function.
It's a function of phi.
0 to 4 cosine.
Perfect. Okay. And they just want the volume, right? So then we're not integrating a function. We're just going to go 0 to 2 pi, 0 to pi over 3, 0 to 4 cosine phi, and then dv is rho squared, d rho, d phi, d theta. Okay? Now let's try to make life as painless as possible. So there are no thetas, right? Do you see a theta? Nowhere. So we can slap on a 2 pi on the outside, for sure, for sure. Okay, I already feel better. 0 to pi over 3. I can't split these up anymore, though. Why not?
There's a phi and there's a...
Yeah, they're not all constants, right? This is a function of phi, so we have to leave it. And then 0 to 4 cosine phi, rho squared sine phi, d rho, d phi. Okay, so first let's integrate with respect to rho. Antiderivative of rho squared.
1/3.
Okay, so let me put the 1/3 with the 2 pi outside. 0 to pi over 3. Sine phi, you go away for a minute. Let me just write this as rho cubed from 0 to 4 cosine phi, d phi. How are you? Good? Okay. You have to cube all of it. So 4 cubed is, I'm going to put that outside. 0 to pi over 3. Then I have sine phi, cosine cube phi, minus 0, and then d phi. Good? We can use sub, right? Yes. Do you need to write it, or can you do it in your head?
Right.
Okay. So you would let u be, good, and then du, d phi. So I have this. I'm just going to pick up a negative, right? So here we go. So 2 pi times 64, that's 128 pi over 3, right? Let me put the minus sign. This would have been u cubed, right? Antiderivative would be,
1/4 u to the 4th.
good, but instead of u, I'm going to just leave it, cosine phi from 0 to pi over 3.
Is that cosine to the 4th?
To the 4th.
Yeah.
Whoops! Okay. Good? Okay. But my ankle's bothering me. Okay. 4 goes into 128, doesn't it? 64, 32. Negative 32 pi over 3 times cosine of pi over 3. Yes.
This is my trig.
To the 4th. You're doing good with your trig. Minus 1 to the 4th. Yes? So what is this? 1/16 minus 1? Negative 15 over 16? I'm going to make it positive and then get rid of the other negative that was out here. Ooh, this is looking so nice. We don't even need a calculator, Professor V. Oh, you don't? Okay, we don't need one for the next test. 10 pi. Look at that. Wow, wow, wow. That's a cute answer. Very cute. Liked it?
Yes.
That was nice. That was nice. Snow cone. Okay.
Give me 37. Actually. 5 times. Since-
Let me just set it up. How about that?
Yeah.
Well, you don't have to do the centroid. Okay. I'll just set up 37.
I think it asked for either cylindrical or spherical.
Yeah. Find the volume of the solid that lies above the cone. Z equals rad. It's a snow cone again. And below x squared plus y squared. I would do spherical. So it's going to be this.
I tried cylindrical, so I was like, I just want to review it.
You want to do cylindrical? Okay, then you have to find the intersection.
Oh,
Because then you have to find the base region in the xy plane. So then you have z squared equals x squared plus y squared. So then you're going to have 2x squared plus 2y squared is 1. So x squared plus y squared is 1/2. So the radius is, there you go. So then your base region in the xy plane, Mustafa wanted to do this in cylindrical, though I would discourage it. It's good practice.
I wanted to
Okay.
practice that.
Well, it's like, but if you're in a math competition, I wouldn't do it. Okay. 1 over rad 2. Because aren't you going to do the integration B in the fall?
No.
Why? What did you win, Nikita? Did you get money? The integration B? Money? That's good, see? Theta goes from? And R? Good. Then you have this picture. X, Y, Z, yeah? And then 1, 1, 1, right? The sphere is centered at the origin. And then the cone's coming through. They love that snow cone, don't they? And then it's here. So you have to figure out limits for Z.
Mm-hmm.
So now you shoot a bullet through your snow cone. Where does it enter?
The cone first and then the sphere.
The cone, and then it exits at the sphere. Very good. So the cone is Z equals,
Rad x squared plus y squared.
in cylindrical, what is that?
It's R.
Very good. Up until the sphere, which is Z squared equals 1 minus R squared.
So rad 1 minus R squared.
Very good. And then from there, you're good? You can
Those
set it up.
issues finding R. That was sort of.
I know. It looks like it would be
I found
nice.
Z, but I didn't find R. I was like, how do you find R?
Uh-huh.
Sorry.
Uh-huh. 1 over rod 2. Okay, perfect. 45. Are we ready? Oh, this one's fun. No, you didn't have a good time doing this one?
Yes.
You did, right? I knew it. Okay. 45. What did we say? You're going to lie to yourself until you brainwash yourself that you like it. You guys read 1984, didn't you?
That was a book on me.
It was imposed on you,
Just like the book.
but you can be brainwashed very easily. You can even brainwash yourself. Okay, you could be like, I love this. This is the best class I've ever taken. I wish she gave more homework. That would be so fun to do more problems. Just keep going until one day you'll really believe your own thoughts. What are we doing? Oh, evaluate it by changing it to spherical. No problem. Okay, so this is E. Let's draw E. In the XY plane, what is the situation, guys?
Circle.
Radius,
2.
how much of it?
All of it.
All of it, correct. Okay, that's easy. Look how quickly you recognize those now. Remember, it was a struggle.
Yeah.
Yeah.
Now it's like, oh, that's a circle. It's obvious. It's obvious. Okay, beautiful. Radius is 2. Okay. Now, we need a 3D picture anytime we're in spherical because you have to see how phi and rho interact with everything. So it's not like cylindrical. Sorry. So we got to figure out what the heck is going on here with the z. So z equals 2 plus rad 4 minus x squared minus y squared. Maybe right now it's not recognizable. So you go, let me rearrange it, try to get rid of that radical. So z minus 2 squared equals 4 minus x squared minus y squared, right? What would you do next to like really say, aha, that's what this surface is?
X and Y squared.
Perfect. So now who is this?
Sphere centered at 0, 0.
It's a sphere centered at 0, 0, 2, and the radius is 2. Oh my God, do you know the equation for that in spherical right off the top of your head?
4 cosine phi.
Yes, very good. Rho equals 4 cosine phi. When it's centered on the z-axis, just do 2a cosine phi. Okay, guys. So it's the all the way around and the whole, okay. 1, 2, 3, 4. So nothing's intersecting it. Yeah, there we go.
It's just a regular sphere.
Yeah, it's just sitting up higher, right? It's not centered at the origin. And it's the whole thing. So can you see how if you stood at the top of it on the positive z-axis and you look down, like if you were standing here and you look down, it would just look like a circle. Radius 2. So that's the picture that we have right here of you standing on the positive z-axis looking down. Okay, so now let's come up with what the limits of integration should be in spherical. So theta, 0 to 2 pi. Phi,
0 to
pi over 2, right? It only is from here up until that's pi over 2. And then what about rho?
0 to 2.
No, look.
0 to 2.
Yes, it's not the same distance every single time.
Yeah.
It's only a constant if the sphere is centered where?
0.
Oh, yeah, origin, right? Okay, 4 cosine phi. And then you have to actually do the integral. Do you need me to do it?
No.
I mean, it's all constant. No, it's not.
Because you just convert it to spherical, right?
Yeah, and then you just go from there. Hopefully you're fine. No? You're not fine?
Isn't it just like rho squared?
Yeah. So you have 0 to 2 pi, 0 to pi over 2, 0 to 4 cosine phi. And then let's look back at the original integrand. So x squared plus y squared plus z squared, what am I going to replace that with?
Rho squared.
Rho squared. And then rho squared raised to the 3 halves gives me
Rho cubed.
rho cubed. And then you have dz, dy, dx, which becomes
Rho squared sine phi rho d rho d phi d theta.
you got it. Can I slap a 2 pi on here?
Yes.
Yes, there's no thetas anywhere. Okay, 0 to pi over 2. We can integrate this. That's rho to the 5th. It'll become rho to the 6th, right? Actually, let me scoot him and move sine phi. We're ignoring you, sine phi. From 0 to 4 cosine phi d phi. Yeah? And then that's pi over 3 on the outside. 4 to the 6th. 4096. 0 to pi over 2. Cosine to the 6th phi. Sine phi d phi. Yeah? And then from here it's the same u sub we just did. U is cosine. Then you're going to pick up a negative, right? So negative pi over 3, 4096. Cosine will be raised to the, so I need to multiply by 1/7. Cosine to the 7th phi from 0 to pi over 2. And then does 4096 divide by 7?
No.
No. Because it was 4 to the 6th anyways, right? And 7 doesn't go into 4. So how could it? That was silly of me to ask. Let's pretend that didn't happen. Okay. Over 21. Cosine of pi over 2 to the 7th minus cosine of 0 to the 7th. So that's negative 1. So 4096 pi over 21. There you have it. It's not that bad. You know my favorite power? I told you guys, right? I didn't tell you? I love it so. Do you want to know why?
3 plus 4.
It's a 7 sandwich. 3 plus 4. 3 plus 4. Plus it's like a palindrome, right? When you have the same 3, 4. Isn't that what you call it? Yeah. And then it's just like, it's 7 cubed. It has 3 digits. There's just so much loveliness going on, really. I couldn't have picked it to be anything better.
No wonder you were so happy about yesterday.
Yesterday? Oh, yes. It was 7/7/25. I don't really love 7s. I think I like the number 6 better, generally speaking. Because I like that you could make it like 2 sets of 3 or 3 sets of 2. It's
A
very...
lot of casinos just have 7s as like the
I
winning number.
know.
It's unlucky.
Because a lot of people think, yeah.
The statistics when you roll dice, if you roll 2 die, you're most likely to get a 7 I think.
Yeah.
I mean, it's because
You know that
it's
from
combination.
stats. Okay, is that everything? We're good?
One more time. You said phi only goes from 0 to pi over 2?
Pi. But in this problem, pi over 2. In this problem, because it's sitting above the xy plane.
Yeah.
Good? Okay, 15:9. Don't forget to like, subscribe, and follow me on Instagram and TikTok, Math with Professor V. I'll be back sooner than later. Mwah.